Right. Good afternoon, depending on where you're listening from. So today will be the the day three of the second week. And last week we looked at, in our last video rather, we looked at exploratory data analysis with NumPy. So for today, we'll be looking at how to visualize this exploratory analysis we've done. We understand that we can perform exploratory data analysis with NumPy, but it will interest you to know that your analysis will not be completed if you don't visualize. So that is why we're going to have a section today on exploratory data analysis visualization. So it's going to be a hands-on section which we will be visualizing some distributions and as well correlations. So our key focus will be on understanding data distributions through visualization. I think in our last video we talked on how we can create data in respect to the use of arrays, NumPy arrays, right? So, but for today, it's going to be understanding that data you've created, the distribution in which that data or the distribution inherent in that data. And that will be done with the use of visualizations. Another thing is identifying relationships and correlations in data. So because we have rows and columns, so as we explained in our previous video, so once you really understand or identify the relationships that occurs and the correlations in our data set. So our major tool will be Seaborn and Matplotlib. So these two guys helps us to achieve effective data visualization. I understand the fact that next week will be for our data visualization. Okay, let's look at the outline. Okay, next week is solely for data visualization with Matplotlib and Seaborn. So, but it's just giving you a heads up with respect to what we've done previously and what we'll be doing from next week. So before you go ahead to do all of this, you have to first of all import the main guy we are dealing with, which is numpy as np and as well as pandas as speedy, right? And then we import another tool known as matplotlib.pyplots as PLT. So that's just the alias name, and then the Seaborn as SNS. So having done that, so let's try to run this code, okay? I will have to restart this all over again so we see it from beginning. All right. So having imported this, we're going to take us on a step-by-step approach on how to visualize our exploration that we've done. So the first step is to load and preview the data set. So should in case you have a data set you want to visualize after you've performed your exploratory data analysis. So it's best you do what you always load the data set into what the notebook you're using, right? So, but now the data set we're going to make use of is iris data. So this iris data is we know iris is a plant, right? And we're going to just look at the data that helps us to know the class of iris plants that we're looking at with respect to what the features such as sepal length, sepal width, and the petal length and width. So with that, we'll be able to identify the species of that particular iris plant. So this iris plant is in Seaborn. So when I mean Seaborn, it's one of the tools that we're using for our visualization. So it's a open library, open resource library, where we can get several algorithms that can be used to plot or to visualize our data. So Iris is actually a data set that has been preloaded on Seaborn. So remember we imported Seaborn here as SNS. So if I'm going to make use of Seaborn, I can say sns.load underscore data set. So mind you, I don't have this data set on my local device, right? So this data set is on SNS. So that's why it's saying sns.load underscore data set, open bracket. We have this guy, Iris being the data set name. And then this is just our dummy. We're trying to print out. So print data sets preview, right? And then print space, empty space. And then the next one is print df.head. df.head displays the first 5 rows. Remember we talked about how to uh, display the first 5 rows in our data frame when we're dealing with pandas. So df.head helps us to do what? To visualize or to preview our first 5 rows in that data set. So data set preview, when you run this code, we will have what? Sepal radar length, sepal width, petal length, and petal width. Then the species is another feature. So all of those are the features in this data set. So we have columns like sepal length, sepal width, petal length, petal width, and then species, right? So with this, we can use it to do us to continue our visualization process. So step 2 is generate summary statistics or statistical summary. So this statistical summary helps you. Remember, we are trying to understand our data distribution and as well perform what? Some visualizations. So your statistical summary will help you to understand the basic statistical parameters that are associated with this data set. So I have here print summary statistics, right? So that's just a title. Then print df.describe. So df.describe is that particular code that gives us what? The statistical summary. Remember when we were dealing with pandas, it told us that whenever we have df, it represents what? Data frame. So data frame is just like when you have an Excel table, right? And then you're trying to see how you're trying to see how to represent your data set in form of columns and rows or rows and columns. So that particular table that is generated is known as what's data frame. So df.describe, open and close brackets, you give us what? The statistical parameters. So we have the counts telling us the total number of rows that we have in our data set. So we have about 150 plants or iris plants rather. And then we have the mean. So the mean will tell us the average of the average of each of the columns, right? So here I have an average of the sepal length to be 5.84, and then the average of the sepal width to be what, 3.05, and the petal length to be what, 3.75, and the petal width to be 0.76. All right. During exploratory analysis, someone will quickly want to ask, why is the species not included in our statistical summary? So statistical summary only accounts for numerical variables, right? So when you have all those variables that are looking like objects, like strings, they will not be displayed on your statistical summary table. So that is why we are having just the sepal length, the sepal width, the petal length, and the petal width. So the counts have explained that the standard deviation for each of the columns give you this and this and this. So if you look very closely, you realize that the data is actually within the range of 0.4 to 1.8. So it's within the range. So I don't think we should be expecting any extreme value. So this table helps you to begin to understand the distribution of your data. See the minimum value, 4.3, 0, 2.0, 1.0, and 0.1, right? And then you go also for the 25th percentile, the 50th percentile, the 75th percentile, and then the maximum value. So another thing that is very good for you to understand the distribution of your data, I know we're going to visualize, but look at this very closely. 7.90 and 6.40. So the difference between 7.90 and 6.40 is very, very small compared to when I should have probably my 75th percentile to be what? 6.40, and then I'm having my maximum value to be 100. So that would be that there is a presence of what? An outlier, or there is a particular set of observations that are very, very extreme with respect to the distribution of my data. And then I have here 4.40 and 3.30. The 3.30 is the 75th percentile for sepal width, while the 4.40 is the what? The maximum value. And also, it will amaze you to realize that right from the mean, the standard deviation, the minimum value, and the 25th, 50, and 75th percentile, and the maximum value. Okay, let's look at, we are looking at sepal length now. So if you look here, 5.8, 0.8, 4.3, 5.1, 5.8, and then 6.4 and 7.9. So all of these guys are within the range of 0.8 down to what? 8.0. So it's very, very, it has a very close range. So we don't expect that when we are doing our box plots for this particular sepal length, we are not doing what? Expecting any outlier. The same thing applies to this guy. I have 0.4, so it's within the range of 0.4 to 4.5. So I'm also not expecting an outlier, right? The same thing is applicable to this one. From 3 point from 3 point from 3.7 down to what, 6.90. So what I'm expecting from here, or the data is within the range of what, 1.0 being our minimum value, down to 6 points, or rather, let's say 6.9 actually, right? Then we have here 0.1 down to 2.5. So it's still within the range. So this alone will help you understand that, okay, this is actually what helps to understand the distribution of the data. Then the step 3 says visualize visualizing feature distributions. So let's try to visualize those distributions and see how they behave, right? So the first is what? This is the code. Don't bother about the code so much now. By next week, I'll be dealing very, very explicitly with each of this code, explaining them from scratch to us, because next week is fully on, how do we call it now? Next week is going to be fully on uh, um, data visualization, right? So if I run this code now, I should be getting what? This is a sepal length, right? So I have that the maximum value in my, the maximum value in my sepal length should be 7.9. So if you look very closely down here, I have here to be 8, and here is 7.9. And then this one are the frequency. So I have more of values between 4.9 to 5.0. I have a high frequency there, and also I have a high frequency around 6.4 down to 6.5. So I have a high frequency there. So this particular thing try to explain the feature distributions of our data set. So if you look very closely, we have sepal length, we have sepal width. So if you see the distribution here, so this distribution, following the statistical principles, we could say that this is slightly a normal distribution, though not fully a normal distribution. And then look at our sepal width. Our sepal width is very, very close to a normal distribution. So when we say normal distribution, it gives what? A kind of a U-bell shape, right? And then if you're coming to your sepal width, remember, when it has to be normally distributed, the mean, the median, and the mode has to be what's very, very close, if not equal. So let's look at the mean. I have the median here to be 3.0, and I have the mean here to be 3.05. So that's very, very close. And I'm also expecting that the mood should be around 3.7, sorry, 3.0 something, right? So with that, I can have my distribution, my sepal width evenly distributed or normally distributed. And then I have the petal length here. The petal length here is showing what? We have high frequency from around 1.5 down to 1.05 or 1.25 to 1.5, right? And then we have this side to be 1.75, and here will be 2. So this is um, um, a positively skewed distribution. The same thing is applicable to petal width. It's a positively skewed um, um, distribution. So when we say positively skewed, I think around the fourth or fifth month, we should be dealing with statistics purely. So when we say positively skewed, it means what? That the tail of our distribution is being rightly positioned, right? So the tail is to the right. And once the tail is to the left, it will now become what? Negatively skewed. Then we have step 4, pairwise feature relationship. So once you see the relationship between pairs, like one to see, let's say for instance, we have sepal length and then sepal width, we have sepal petal length and petal width. And then we want to see the distribution with respect to a particular feature. And the feature we are looking with respect to is the species, right? So we want to make a distribution plot or a pair plot to see how this petal length behaves when I'm trying to understand it with respect to the species. So I have the species here, Satosa, Versicola, and then Virginia, right? These are the 3 species. So I'm giving them a color code, yellow for versicolor, and then I have green for Virginica, right? And then I have blue for Setosa. So if you look very closely here, for my sepal length, with respect to sepal length below, I'll be having a normal distribution for Setosa, and then I have another normal distribution, though it deviates from that of Setosa for versicolor, right? And the same thing is applicable for the last one. So, but when I now try to visualize this, okay, why this is giving us a normal distribution for the first plot with respect to sepal length is because when you're plotting a variable against itself, it should give you what? Either a normal distribution or a straight line distribution. So that is because the numbers are consistent. So it's just like when you're looking for the relationship between A and A. So it always give you what? A correlation of 1.0. So that is why this guy is being what? Normally distributed. So the same thing is applicable for sepal width with respect to sepal length. So this one will give us what? It's just a scatter plot. Then it will be organizing the species. So if you look at the color code, it's telling you how the species are being arranged. So let's run this. Our time is fast spent already. All right, so let's run this and see what it will output for us. So we have the same code displaying what we just explained. And then the next step is correlation analysis using heat map. So this is where we now see, okay, because we've been saying this guy is normally distributed, this one is a scatter plot, and this one is what deviating and all of that. But we want to see how they correlate between themselves or amongst themselves. So I have that. I have this code here, sepal length, and then sepal length down here, right? So if you see the correlation between sepal length and sepal length, it will be what? 1.0. So following this correlation principle, the closer the value is to 1.0, the strongly positive or the positively strong the correlation or the relationship between those two variables. So it means that for sepal length and sepal length, the relationship is very, very strong. So that's why it's having what? A 1.0 score. And then if I look for this other one, sepal length and sepal width, I'm having a minus 0.12. Mind you, when you're traveling from 0 to 1.0, it's what? Um, positively correlated, very, very positively correlated, right? Then when you're going the other way around, from 0 to -1 is negatively correlated. Another way of explaining this guy is that as you're going from 0 to 1.0, it means that those two variables you're looking for their relationship or their correlation, they have what? As one is increasing, the other one is also what? Increasing. So they are directly proportional. I'm bringing in proportionality, trying to marry it with what? Correlation. And then the same thing is applicable when you're going the other way around. It means that one is going up and the other one is coming down. That's why there's what? A reversal. So that kind of correlation is known as what? Is known as inversely proportional relationship. So when you're trying to see the difference between or how these two variables correlate, then having explained that sepal is giving us 1.0, then this sepal length and sepal width is minus 0.1. So just this will give you all what you need. Then the next step, I don't want this video to be a long one because I will need you to do a whole lot of work for me. So the next step is what? We want to box plots. Box plot is the next thing. Don't worry, I will explain all of this for us. So box plot, I have the first one is box plot of sepal length by species. Mind you, box plot of sepal length by species. So I have the Satosa, versicolor, and Virginica, right? So this is how the box plot looks. So this box plot, I'll explain it when it comes to that time. So let me rush and round up this class because our time is fast spent already. So the next should be violin plot. Violin plot is used for what? Detailed distribution analysis. I didn't tell us what this guy is used for. Distribution of features across species. So this one is used for distribution of features across species. This guy is your maximum percentile. That's 100%. This one is your 0 percentile, 25th percentile, 50th percentile, and 75th percentile, just like we explained from there. Then for violin, violin is also kind of distribution, but then it's more detailed because it gives you where the 75th percentile falls and then where the 25th percentile and the 50th percentile falls. So in conclusion, histograms helps to understand what the spread of numerical features. So this class today is just a heads up with respect to what's going to happen next week. So by next week, when I'll be explaining most of those things, it will not be new anymore. Then pair plots shows relationship between what numerical variables across categories, while heat maps visualizes what feature correlations, and then box plots does what box plot and violin plots provide insight into what feature distributions by category. So that explains that. So I have a little exercise here for you. The first is what you modify the code to visualize the distribution of petal length across species. Remember we did sepal length across species. So you do petal length across species using box plot, and then you create histogram of sepal width and analyze its spread, right? Then using different data set, example, you could use ping use from Seaborn as well, and then you have to perform this similar EDA steps we have already explained. So the next step should be apply these techniques on what's the data on your own data, and then experiment with additional visualization styles, preparing for our next week class. So the video will be uploaded shortly.